In continuation of Ohm's law. So this one, Ohm's law, is derived from the name of the one who proposed this kind of principles of electricity under Ohm's law, George Simon Ohms. His name was George Simon Ohms. So he was the one who gave this proposed Ohm's law, in which he described that the current is directly proportional to the voltage and inversely proportional to its resistance. As we all know, and we are very much familiar, what are the units under the quantity of current, voltage, and resistance? I'll repeat. Current, the corresponding unit is amps or ampere. Voltage, it should be volts. Resistance, it should be ohms. So again, guys, those are the important components under the quantity and units of Ohm's law. So how you should be thinking about electric circuit? When we find out about voltage, it is a force, although we have been discussed this in our previous topic presentation. A force that pushes the current through the circuit. In this picture, it would be very equivalent to the gravity. Like waterfalls, the falling of water. We can see the movement, how the water flows, downward. It can also be visible through the running water from the streams or rivers. Sometimes the flow of water is calm, sometimes it's fast. It depends, the depth of the water. Then the other one, how about resistance? So when we say about resistance, if we are going to relate this in real life situation, resistance, it is a friction that impedes flow of current through the circuit. So it helps to block or slow down the flow of water. In this case, in this equation, that will also be relatable to the flow of electricity. So rocks, blocks, or slow down helps to resist against the flow of the river or the flow of water. So that is why we call it as resistance. It helps to impede or block the flow of the water, which mainly we represent as flow of current. So, actual substance that is flowing, we call it as current, the actual substance. That is flowing through the wires of the circuit, that electrons present, right? So how does things work? So in our literal understanding, if we heard about battery, light bulb, wiring components, that's all about electricity. But we have to understand first the diagram, schematic electric circuit diagram. No? We have to analyze the chart or the diagram first. No? What is the job? What is the function of a battery? How the light bulbs function? What's the function of the switch on and off? Okay? Can we arrange this one through parallel circuit or series circuit or multiple structure? Right? So how would this work? In our concept, when it comes to closed circuit, so this is what we call the closed circuit. But what do you think? Is this working or not? In this diagram. So let's explore further about circuit diagram. Scientists usually, this background of electricity, when it comes to theory and concept, just only a simple understanding, like you guys as a student. Okay? Scientists, teachers usually draw electric circuit using symbol because, okay, we call it as schematic diagram. Scientists usually draw like this. In our simple structure, we might use linear shapes. So this one, instead of using a picture or by drawing a picture of real life battery or bulb or wire or switches, we can use lines to represent what we call schematic diagram. To represent the battery, the line that connects, that is a wire. Then, we also have positive and negative terminal, and then the switch. Those are the four basic components of materials when it comes to electrical circuits. You understand? So you have to remember this symbol. This is a cell or battery. Next one is a lamp. Then this is the symbol of a switch. Then the linear one is wires. Now let's talk about simple circuit. So in a simple circuit, it is a series of circuits that all in a row. One path for electricity, one light goes up, and the circuit is broken. Okay? So simple circuit have two important components to remember. One, series circuit. Two, parallel circuit. So I'll repeat. In parallel circuit, these are composed of many paths. For electricity, one light goes out and the other stays on. It's because the electrical wiring component connects from one end to end. Okay? However, in series circuit, all in a row. This is a shortcut way for some electricians, the way they install. It depends on the area or the structure when it comes to electrical installation, either in household or any places. Parallel circuit, as I've said earlier, many paths for electricity arranged. So some electricians might consider this for safety purposes. That's the reason why. Some of those arrangements might be series circuit, parallel circuit. If your house has a lot you have a lot of appliances, okay, that you usually you're using every day or even every night. So we might consider about the different simple circuit component when it comes to proper installation of electricity. So series circuit can connect, no? According to its arrangement. So this one, the measuring equipment, we already discussed this earlier. No? The electric current is measured in amps, okay? Using the measuring equipment to test the current, that's ammeter, connected in series in the circuit. So measuring current, how we draw an ammeter in a circuit. So this one for a series circuit, then the other one is for parallel circuit. So measuring voltage, electrical push. This is really where the pressure or force coming from. And literally, this is known as battery or cell. Okay, so the source of number of volts, 100 volts, 250 volts, 1000 volts, those are the different load capacity of a battery. Depends on the usage and the component or devices that you're going to use. So this is always measured in volts on a voltmeter. So measuring voltage, this is how we draw a voltmeter in a circuit. Okay? So between series circuit and parallel circuit. Okay? So we emphasize also the number of volts in a battery. So what Ohm's law is all about. So this helps to measure the current voltage across its circuit. So what is the role of this principle under Ohm's law? So this helps to compute the resistance either in a series circuit or parallel circuit. Okay? So always remember the three important components: voltage, the current, and the resistance. So measuring the current in a series circuit, current is the same at all points in the circuit. While parallel circuit, current is shared between the components. So in this example, okay,